Good afternoon, folks. Thanks for being here. Thanks for joining us at the IP Showcase. My name's Paul Atwell. I'm here this afternoon to introduce Stefan from Simplexity, who's going to talk this afternoon some more on 2110. Thank you, Stefan.
Thank you. A bit louder. I speak up or I go very, very close. Cool. Thanks for coming. Welcome everyone here at NAB 2023 here on the floor, but also welcome those people who are going to watch this afterwards. IP works until it doesn't. Imagine yourself to be the guy who pushes the button and expects some connections to happen. You want to see some pictures, you want to hear some audio, and you don't. Or you hear just distorted audio or something like this. Now, what are you going to do now? You can obviously go and call your colleagues who are the experts on all of this. Maybe you get nervous, whatever, but it's definitely not a cool situation to be in. And so what to do about these situations and how to avoid them. So that's going to be what I think I want to kind of talk about today, but let's start from the beginning. Who am I? I'm a part of a company called Simplexity. We are based in Zurich in Switzerland, and we do consulting and training mainly for audio and video over IP, 2110 all the way to Dante, NDI and stuff like that. We are manufacturing independent, and we just like to be part of as many projects as we can because we want to learn as much as we can in order to give it back to our clients. So we do have quite some experience with some 2110 installations already, and one particularly which I want to relate to here, and that's one of the, I guess, pioneering all IP projects in this world, the Swiss TV SRF project Metecno in Zurich, and they have chosen to do what they call a greenfield approach, and they have also chosen to not go with some few vendors. They wanted basically as many vendors as it takes, and they want to choose the best vendor in each category. So they said we're going to challenge the industry for interoperability between those vendors. And the hot seat in there was mine to actually coordinate the integration between those 17 vendors and the orchestrators. So that was quite a cool job to be in, learned a lot. And that's also, you know, one of the backgrounds I want to use for today's presentation. So, something we observe quite a lot is, first of all, people are at the beginning of a project concerned about 2110, but we believe it works. 2110 is kind of matured over the last years, and it's pretty cool. But the challenges in all these installations are the control layer. That's where the whole complexity comes in, and it's really not easy. And I used to say to our customers, your biggest challenge in your project is probably reducing complexity. And this huge complexity you're facing in these projects actually obviously then leads to the fact that you need to simplify some things, at least for the first steps. And that means you compromise certain things during the project. It means very often you lose flexibility of the network because you just want to keep it that way it is and you're sure it works. So, okay, let's just do it exactly that way and I'm happy with it. So, we can go on air. And one of the topics is monitoring, which very often gets pushed back. No one says we're not going to do monitoring, but it's not first priority. Let's get it all up and running first. So for time and budget reason, it gets pushed back. And actually, I know quite a few installations which are now on air, and they're basically operating pretty blindly if it comes to IP and the networks and the flows and all this kind of stuff. It's not that there aren't solutions around, don't get me wrong, but it's kind of an afterthought. So as a consequence of all of that, many of these installations are largely static setups. Basically, you could be a bit challenging and say, well, we basically rebuild what we had before in SDI. But actually, people try to avoid this unpredictable network dynamics, which is fine. You know, I totally understand that. But actually, one of the main reasons to go to IP is flexibility, right? That's one of the main reasons why we want to go there. And I see a lot of loss of these flexibilities in real life projects because people connect it in a certain way and then they're happy that it just works, don't touch. But wouldn't be network about flexibility, as I said. So audio over IP, I believe, shows its full potential if you start using it in a dynamic way. Remove a device from A, go over to B, connect it again, whatever, all this kind of stuff. Oh, I need a few more of these. I take it out of my basement, kind of, or I rent it in. Have you ever seen anyone renting 2110 equipment over the weekend? It's just not happening. So, but actually the IP and the IT industry has a lot of solutions. They are largely flexible. I just brought here 2 examples where IP is flexible. Example, DHCP. It's been there for years. And now how many installations in broadcast do you know using DHCP? Mostly static IP addresses, and that's the way it is. Another example is the whole, layer 3 routing, which IP has beautiful solutions for, with the whole layer 3 stuff, with IGMP, BGP, all these routing protocols. But broadcasters tend to use interface-based SDN orchestrators. So here's interface number 3, and that's exactly where you get that signal. And if you move to interface number 4, there's no signal on there. So it's basically rebuilding SDI matrices in many cases. So we want to kind of claim and maybe also challenge the industry a little bit that we think audio and video over IP should be flexible and should be made flexible. That's the next step. And for that, we actually thought about some reasons why potentially we are not doing it today. And I think one of the key points is traditional broadcast requirements. People, not so much nowadays, but like 2-3 years ago, people said, I want to have a clean switching system. I can't let go of that requirement. Or you're going for all kinds of stuff like this. So basically, we need to rethink some of this because maybe the IP world doesn't give them for free. If you actually want to have it, it's quite costly and it's probably very proprietary, all this kind of stuff. We had confidence in SDI, AES, whatever, MADI, because we know the technology, we understood it. The audio and video engineers knew how it works. And also because we knew it's made for us. This equipment is made for us. It's for audio and video applications, broadcast, what have you. So we had this trust in that equipment, and now in the new situation, A, most audio-video guys are no IP experts, and B, the technology as such is inherently more complex than SDI or whatever, MADI and AES3. It is more complex. I don't think, we can't deny that. So the network often appears as kind of a magic box for traditional guys. So you actually, the result is kind of almost a fear of it. It's the respect and kind of, I don't know what I'm doing. So, and actually I think it's a big loss that people don't feel in control. Here's the system, I'm going to tell you what to do. And far too often they think like, something's wrong, or I want to avoid doing too much today because I'm afraid of it breaking down or whatever. So there is a missing trust in the technology, and a lot of people, they get it up and running, and then over time they start to trust the system until they have an incident. And then that's kind of disastrous. So as I said, many of these projects are reduced to smaller steps, and in many of them, the monitoring and the feedback to the user, hey, I'm okay. It's all good, don't worry. That feedback is missing in many cases. So, what do we propose to achieve flexibility and, let's say, to use a network in the flexible way as intended by the IT guys originally? We think that, first of all, it's about gaining confidence. And we gain confidence because by giving feedback, we believe you need constant surveillance in your system. And what I'm saying is not checking the status of your switch. What I mean is the system. That's where you actually send signals from A to B, and you want to check B, do you get the signal? Are you okay? Do you get all the packets? Is there a problem with PTP? All this kind of stuff. So basically the probe for your surveillance system should be the end device, constantly. Because you don't want to connect a new device to it and check, oh, does this analyzer show me some problems? So the end devices should actually report back if there is a problem. They know when they change the grandmaster. They know when they lose lock or when they lose packets. That's inherently in their nature. They just have to tell you. So the other thing is, if we show green states about the network, we believe the manufacturer has to make sure that green means green. You should never hear audio or video problems and still have a green light on your controller saying everything's cool. The moment that happens, you lose trust in the controller. And it takes a long time and many software upgrades until you tend to get it back. The other thing is actually the way you notify a user about a problem. The audio-video guys are no IT experts, so you need to notify it in a way, in a text, in a whatever, saying, hey, you got some I don't know, oversubscribed bandwidth somewhere, whatever. Then it needs to be a target user, the target user is not an IT guy, so then the messages must be made simple. And finally, the messages about state of your network should appear where you operate the network and not in some PC somewhere in the corner. So basically, where I operate, I don't know, XY panels, all this kind of stuff, that's where I want to see an alarm if something's going wrong, nowhere else. I want to hit that take button, and if it lights up green or whatever, it's green. So it sounds so kind of clear when we list those things, but now again, check your experience, check your systems. How many times did you actually see these four conditions, let's say, met in a system, in real life? So we think if you do surveillance, that's the next thing. If your system is a different system surveying your network, which might be okay, totally fine, then it needs to be tightly synchronized with your control system because the state of your signals constantly changes. How could an external or third-party monitoring system know that there should be packets going to this interface unless it gets told by the control system constantly? You could argue that the monitoring system should be the control system. But I'm not saying that, but at least it has to be tightly synchronized because just overlooking your switch state is not enough. So, again, I think the probe to your network must be the end device. And so it seems like a huge challenge to do that, but I think it's actually not that complicated. We come to that in a second. The last point in here is actually also something which is unfortunately not always the case. Alarms by these devices must be sent actively. It's not like they need to tell you, hey, I got a problem. Because otherwise, a monitoring system needs to know what should be the state and then needs to compare, or let's take just the simple stuff, a temperature. An end device or device reports you, 75 degrees of temperature. Well, that might be hot, might not be hot. So for control system guys, monitoring guys, they will tell you, for us, it's heaven on earth if the end device tells us I'm too hot. Because the manufacturer of that device is the only guy who really knows that. So, this is all based on a true story. And I would just want to go back to what we did in the Swiss TV in that case. So this installation is up and running and working very well. And people see IP is really cool. So that's good. Now there was a phase 2, always pushed back slightly, called surveillance. And as I said in the beginning, and there is no exception to this project, it seems to be like not that urgent, so let's push it back, the whole surveillance. In this case, I'm happy to lead some of these discussions to actually get it up and running. And what happened there is we have like a couple of vendors, and we have discussions how to do it best, how to report the status of their end devices and stuff like that. And we went through so many rounds and so many pages of possible telemetry, alarming, state, whatever information which we found useful. And with all this, we also said, well, there must be active notification, no polling constantly, because it kind of loads our network far too much. But also the manufacturers said, whatever you're asking here, cool, makes sense, but this is far too complex for us to implement. It's going to take whatever. And by the way, it didn't say that in the contract. So then it's kind of difficult. So we all agreed we need to reduce our long lists of monitoring requirements. And now the absolute minimum, we ask ourselves, what's the absolute minimum we want to get reported from end devices? The total minimum, and which helps us a lot. And now the thing is, we wanted to propose, or we will propose, these alarms which we came up with for standardization. Because that would be really cool. If every end device, every NMOS end device reports this minimum set of alarms. And here's the good news. It's not pages of alarms and status information anymore. It's actually 4 specific alarms. And that's it. 4 alarms. It's not hundreds anymore. I'm not saying the others don't make sense, don't get me wrong, but we believe with these 4 alarms, you can tell a lot. What are the 4 alarms? First one concerns connectivity of your system. You know, people walk up to systems, disconnect cables or whatever. So the first one is link down. Easy to report, but you know already, hey, someone disconnected a cable. I don't need to look any further, it's disconnected. Simple. Second one, packets lost. Or let's say, maybe late packets. It's kind of the same thing, or it's very similar to it, very, very close to each other. If you know that a certain device loses packets, this is very valuable information, because something is wrong. And you know already there's something wrong with traffic and, as I list here, with connectivity. Something there, they don't all reach the destination properly. So the third alarm concerns synchronization. Surprise, surprise. Grandmaster change or PTP unlock. Relatively easy as well. You know, hey, I got a new Grandmaster. Well, that doesn't just happen without a reason, and the reason is probably not what you want. So, and then the final one then goes more in a higher level, connection management. And that means, basically, I can't decode the RTP stream, whatever reason. So I'm not saying there should be more, would be cool to have more information, but to have the information, there's an invalid stream format, that tells you already a lot. So, these are just 4. And I'm going to show you in the next slide just some practical situations, and I'm going to prove to you that these 4 alarms already tell you quite a lot. Not everything, but a lot. So, I just listed some potential practical problems in a network. Cable disconnect, I already mentioned that. On the right-hand side, you see which alarms would most likely trigger if that's happening. So, for instance, obviously when you lose a connection, a link, then you also get lost packets. So some alarms will be doubled. Another one is aging SFPs, dirty connectors or whatever, link flapping, all this kind of stuff. Again, same story, it's very valuable to know, hey, I've got a problem on that link. Then your PTP leader may be degraded. Let's say you lose GPS, whatever, all this kind of stuff, you get notified. And again, the notification should happen in the control system. Then The next one seems kind of unnecessary. Wrong PTP domains, wrong PTP profile settings. Well, it doesn't just happen accidentally that a device changes its PTP settings. Well, true, but we want to be flexible. That means people are starting to connect devices to your network. They come in with new devices, and they may set them up in an incorrect way. So that's kind of stuff which actually, in a flexible way of working, becomes a real-life situation. Then any kind of incorrect packet forwarding, you have some IGMP, PIM problems, whatever, you would basically also see that there is packets getting lost. Unexpected high traffic. So if you overload links because you did something wrong, you would also get, let's say the query problems, whatever, all this kind of stuff. I guess you will then pretty soon see late packets or lost packets if that happens. Then, my favorite topic in the audio guy, being an audio guy, link offset. The latency settings. A lot of video guys don't know about them. They simply don't expect them to be there. But if you choose them far too low, you will get lost packets. And again, I just remember one case in another installation where a customer said, occasionally we hear distorted audio. And it sounds like zzz. That was the description of error. Okay, and clearly there were packets getting lost because they had a too low link offset. Then incompatible stream settings of whatever. Some device does not understand the settings or the stream. It will tell you, hey, I am not able to decode that stream. Let's say too many channels in there, whatever, all this kind of stuff. And finally, multi-use of the same multicast address. And not that rare, in a dynamic system where obviously multicast addresses get assigned dynamically, not just like via Excel. Then you obviously you could run into these kind of situations, or someone types in a static multicast address in a device, and for some reason it starts to use the same multicast stuff. So you would get an invalid stream because the packets don't match. So this is just some practical examples which could be covered by the 4 alarms. Now again, I'm not saying this is the end of the story, but you're 90% there. So we believe if these 4 alarms are reported on an interface basis, so if you have -7 redundancy, we should know which link is disconnected, of course, or which link gets late packets, or all this kind of stuff. Then you are able to actually circle quite a lot of your practical problems. And if they get reported by the end nodes, and that's an important thing, they serve you as constant probes in your network, and that's exactly where you want to actually know whether things go wrong. So, and that would allow us, we believe, to move forward into using the networks in a more flexible way, rather than just keeping it static because we're afraid of changing or whatever. We could take more risks, let's say, and see whether things go right. So for those of you who are familiar with the EBU pyramid, they always come out with red and green and where the industry is. Basically, the summary is, what I'm talking here about is this. And it's pretty kind of yellow, reddish. And that's really what I'm saying. I think we don't need to go very far. We need to these 4 alarms, and then we are 90% there. Being very pragmatic here. So then you could have a dynamic IP system, and you could gain confidence that it works because everything reports its alarms actively. And if we would manage to standardize those 4 alarms in NMOS, we wouldn't have to implement them for every single device, because that would really be heaven on earth. Imagine you had an ISO 4, ISO 5 setup, and an IS, 12, 13, 14 implementation in every device, and you know what they're doing and you know they're healthy. So that would be a really cool thing, and I think for our whole industry and for NMOS a big step forwards. So, thanks a lot for listening. Open for questions here, or we can move on the other side, whatever. Yeah.
So, do you also want to standardize or specify how to alarm? So which protocol, which format of the message and stuff?
Yes, because you don't want to write drivers. So I would suggest, because it's close, IS-12, because IS-12 for the first time ever in NMOS history allows you active notifications. So I would hope, and I proposed it already to the group there, that they should look at this even as a test implementation of IS-12.